Okay, so we've looked at simplifying problems involving fractional exponents. We now move on to simplify problems involving radicals. Consider, for example, the problem x cube root of x squared times the fifth root of x. Cube root of x squared times the fifth root of x. Now, we don't have any rules for simplifying things with radicals. But what we can do is take our radicals and convert them over to exponents. So cube root of x squared would be x to the 2/3. Fifth root of x would be x to the 1/5. We can then proceed by using our properties of exponents to simplify. So here we're multiplying, so we add the exponents. So 2/3 plus 1/5. Get a common denominator. Get 10/15 plus 3/15 would be 13/15. And now we rewrite that. That would be x to the 13/15. But because we started with a radical, we want our answer to be a radical. So now you have the additional step of converting back to radical. So remember, the root comes from the bottom. So that would be 15th root of x to the 13th. 15th root of x to the 13th power. Okay, let's consider the next example. Here we have a division problem. Fourth root of x divided by sixth root of x to the fifth. Again, what we do is we convert first two exponents. That gives us a problem we can do, because we're dividing now. We subtract our exponents, 1/4 minus 5/6. Again, we get a common denominator, and we get the answer negative 7/12. So this will be x to the negative 7/12, but again, negative exponent, we got to get rid of that by moving it. And then again, because we started with a radical, we want our final answer to be a radical. So we would rewrite that as 1/12th root of x to the 7th. This next example really throws a lot of people off. Fifth root of the square root of x, so we have a radical nested inside of another radical. Well, the key to this is to realize that square root is the same as raising x to the 1/2. And when you have a fifth root, that's the same as raising it to the 1/5 power. So we can rewrite that as x to the 1/2 raised to the 1/5. Then we use our properties of exponents. 1/2 times 1/5 is 1/10. And then writing it as a radical, be 10th root of x. Now, in the next problem, we actually have three radicals being multiplied, but the process doesn't change. We still convert them over to exponents. And then since we're multiplying, we're going to add up those three exponents, or those three fractions. Now, this may take a little bit of work. You may want to take a moment and try to do that. The common denominator that we're going to need is 60. So that would be 20 out of 60, plus 45 out of 60, plus 24 out of 60. Add across our numerators, we get 89 out of 60. So this will be x to the 89 out of 60. We can rewrite that as a radical, 60th root of x to the 89th. And then we say, oh wait, we got one more thing we got to do, because the thing inside that radical is bigger than the root we're taking. So we still have to simplify if we need to. That didn't come up in our problems we did a few moments ago, but it did here. So the biggest thing 60 could go into would be 60. So we could write that as 60th root of x to the 60th. And then you have 29 things left over, 60th root of x to the 29th. 60 goes into 60 one time. So we get x to the first, or just x times the 60th root of x to the 29th. So sometimes, particularly with the ones where you're multiplying, you may end up with a radical that you need to do some work to still simplify. Okay, till next time.